Hello and welcome to Java Programming for Beginners. I'm Sai and I'll be guiding you on getting started with Java programming. Java is a popular language that is used in developing different kinds of applications such as web applications, Android apps, scientific apps, enterprise applications, and so many more. This video is packed with knowledge to help you learn Java. We'll cover core Java concepts such as classes, objects, encapsulation, etc. We'll learn to write robust and reliable code while learning to handle exceptions. We'll also build a small console game while learning the control statements provided by Java. So let's get started. To develop Java programs, we need what is called as Java Development Kit or JDK for short. To get the JDK, you can head over to google.com and type JDK download. Click on the link which says oracle.com. And you'll reach this page. As you can see, the JDK is available for Linux, Mac OS and Windows. Select the OS installed on your computer and then click the correct link to download the installer file. Once downloaded on your computer, open the file and the installer will guide you through the installation process. Next, we need a code editor to build our programs. I'll be using Intellij for this video, but you are free to pick alternatives such as Eclipse if you prefer. Although it might be easier to use the same editor as me if you are going to be coding along. Head over to google.com again and type Intellij in the search box. Click the link which says JetBrains and it will open the Intellij page. Click the download button and select the correct OS for your computer. Download the free version called Community Edition as it is sufficient for learning Java. Once you have downloaded the installer, open the installer and it will guide you through the installation process. Once installed, open the editor. Once you have opened Intellij, find the option to create a new project and create a new Java project. Select the correct SDK. In this case, it is the JDK you've installed on your computer. Make sure you have selected Java in the left hand side and the correct JDK has been selected in here. Click Next. Keep the checkbox unchecked for now. Click Next and you'll be prompted to pick a name for your project. I'm going to name this project Hello Java and click Finish. Let's start off by writing a simple program which prints Hello World onto the screen. In Java, the class forms the basic building block for all programs. A class is the template or the blueprint which we use to represent a state or behavior in our code. We often need to represent things from the real world in our code. This is done using a class in Java. For example, we can have a person class, student class, machine class, etc. Using this class template, Java allows us to create class objects or instances of a class. While objects of a class can be unique, they share the same basic characteristics. For example, John and Brian are two different people, but you can say that John is of type person and Brian is also of type person. Speaking in Java lingo, both John and Brian are objects of class person or type person. Similarly, we can have a class car and create multiple cars in our code which will be the instances of this class. Objects of one class or type often need to interact with objects of another class. This is how programs can accomplish complex tasks. This is the basic principle of classes and objects in object-oriented programming. Java is an object-oriented programming language. Let's create a simple class and we'll name it Hello Greeter. Inside of Intellij, we can see the project name Hello Java and there is a subdirectory called source or src. We will add all our code inside of this src folder. So this is our first class called Hello Greeter. In this class, you can see the keyword public. The keyword public is called access modifier and conveys information about the class's visibility. A class with public visibility can be seen or accessed by another class. The keyword class itself tells Java that we are defining a class by the name Hello Greeter, and curly brackets indicate the start and end of the class body. In Java, classes contain functions which are blocks of code that can be called upon to perform a specific task. These code blocks are also called class methods. In Java, methods have to be inside of a class. We can call one method inside another as we will see shortly. Let's first define a method to print Hello World. This is a statement in Java and most statements must end with a semicolon. Here we have defined a class method print hello and it has public visibility as indicated by the public keyword. We use the void keyword to indicate the fact that we do not wish to return any value from this function. To run this method, we need to call it, and to do that, we need to create an object of this class. To see our hello world message on the screen when the program runs, we need to create the object of the hello greeter class in the main method. This is the method that Java will call to run our program. The main method is the entry point of our application, and as you can see, there is quite a bit going on here. So let's break it down. The method is defined with the keyword static because it will allow Java to call the main method of our class without creating an object of this class. The text here, string with open and closing brackets, tell Java that this method can be provided with a bunch of text data or strings when it is called. In this line, we are creating a new object using the new keyword. But to call our method using this object, we need to assign it to a placeholder, and this is called a variable. We define a variable like so. We can then call our class method like so. Now to run the application, we can click on the play button and select run. You can see the console here with the message hello world. Congratulations, you've got your first Java program running. The message we printed on the screen is of type string. What if we wanted to use a number instead of string in our code? To achieve this, we need to create a variable of a different type other than a string. These types are called data types, as they indicate what's the type of data that they are holding. Java provides a wide range of data types, and these fall into two categories. The first category is called primitive type and the second category is called non-primitive or reference types. Let's look at some examples to help understand primitive data types. We'll create a variable to store a number by using a primitive type called int. Here the variable x is assigned the value 10. Now let's look at a reference type. Here I have a variable called message and it's of type string and its value is the string hello world. Our class hello greeter is also classified as a reference type. Another popular primitive type built into Java is boolean, and a variable of type boolean can hold the values true or false. For example, if you wanted to indicate a fruit was safe to eat, you'd write this. What if we wanted to pass some extra information when calling a method belonging to a class? Let's say we'd like to pass a person's name to the method so that it prints a message to the screen greeting this person. This can be done by passing in what is called as method parameters inside the brackets and telling Java the type of these parameters. Let's create a new method called greet and pass in a person's name. In this method, the parameter name is of type string. Now let's build the message we'd like to print onto the screen. We can combine two strings using the plus symbol. Let's define a new variable called message and store the message inside it. Now we can print the message using system.out.println. To call this method, we can use the hello object again. Let's pass in the name of the person. Now let's run this method and see what we get. Here we can see that it's printed hello Brian. We just saw that we were able to join two strings using the plus symbol. This is called an operator in Java. There are a bunch of other operators for performing mathematical operations. For example, we have the asterisk symbol for multiplication, the dash symbol for subtraction, the / for division. Let's look at some example of using these operators. Let's say we want to implement a simple calculator. We can start by defining a new class called calculator. In this class, let's define a method to add two numbers and return the sum. Because the sum of two numbers is a number, Let's call the method add. Because we want to add two numbers, we need to pass two parameters of type int. Let's add these numbers and store the sum in a variable called sum. Now to return this sum, we need to do the following. Here we're using the return keyword to return a value from this method. Let's add another method in this class to divide two numbers and return the result. Because the int data type represents a whole number and division can result in a fractional value, we can use a different data type called double in Java. Here I am dividing a by b by using the division operator and storing the result in a variable called quotient, and then just returning the quotient from this method. Now let's try and use our calculator by first creating an object of this class. We can again define a main method and create our object inside of it. Let's add two numbers now. Here I'm passing in two numbers to the method add on the object of the class calculator. You can see that Intellij is telling us that the value 3 will be assigned to the parameter a and the value 5 will be assigned to the parameter b. So when the method add is called, it will add the two numbers, assign it to the variable sum and return the sum back to us. We can store this into a variable as well. So here I want to print the variable sum. For that I can simply append the variable sum to the existing string using the plus operator. Let's run this program and see what we get. Alright, as you can see, it has printed the message on the screen and it has printed our sum as well. That's great. So you might be wondering how the variable sum was printed into our console. So the method println will convert the int into a string and append it to this string, and that's how it was able to print the entire message onto the console. Now let's divide two numbers and print the result as well. I'm calling the divide method and passing it 8 and 3. This method will then divide 8 by 3 and return us the result which we are printing in this statement here. Now let's run the program and see what the output looks like. If you look at the output, we can see it's printing the result as 2 when you divide 8 by 3. But we know that 8 divided by 3 is actually not 2, but it's 2.66. Let's go back to our divide method. So here we have two int values a and b, and we are dividing a by b. In Java, when we divide two integers, the result is stored into an integer automatically, and as a result of that we lose the numbers after the decimal. What we need to tell Java is that even though these two numbers are of type int, we want their value to be converted into a double before assigning it to this variable. To do that, we can use the casting operator. Now let's try to run our method again and see if it works. This time we can see that we have all the numbers after the decimal in our result. That's great. Now that you know how to create objects, let's learn what class instance variables are. Let's say we want to represent people in our code. First, we need to create a class to represent a single person. So let's first define a new class called person. Since every person has a name, let's define a string name inside this class. Now let's add a method to print the person's name. Now let's define our main method. Let's create a new person object and let's call it Brian. And let's try to print the name. Now if you look at the output here, we got null as the name of Brian. A null means there is no value present in the variable name. And this is because we need to provide the name for the person object Brian. One way to do it is to pass in the person's name when creating the person object. The code will no longer be valid because Java cannot find the method person which takes in the person's name. Such a method with the same name as the class is called a constructor. Let's define the constructor for the person class. This method has a parameter name of type string, and what we'd like to do is we want to initialize or set the value of the person's name when the constructor is called, and the constructor will be called when we use the new keyword and we pass in the name Brian. So in this case, we want to say name of the person equal to name in the parameter. And now it looks a bit confusing, isn't it? Because you can't tell which name variable is the field name and which one is the parameter name. To get around this, Java provides the keyword this. Here we are telling Java to assign the value in the parameter name to the class instance variable or field name by using the this keyword. Now our program should work as expected. If you look at the output, you can see the person's name is Brian. So far so good. Now let's see how two class objects can interact with each other. The most common way for one class object to talk to another is by calling methods on the object. Let's try to make one object of the class person say hello to another object of the same class. Firstly, I'll define another person, John. Now what if I want Brian to say hello to John? We could achieve that by doing something like this. Now the code editor has highlighted this method name in red. That's because we haven't defined it yet. Now let's print the hello message. And now my message is name, which is the name of the person I'm calling this method on, and it'll say hello to the person whom I'm passing in as the parameter to this method. Let's now print this message. So in the output we get Brian says hello to John. Here we made one class object Brian say hello to another class object John. Now let's see how two class objects of different classes can interact with each other. Let's say we want our person object to drive cars. We need a way to somehow provide a car to our person, say Brian, so that he can drive it. Firstly, let's define a car class. We want to know the make of this car, so we'll define a field inside this car called make, and it will be of type string. We need to initialize or set the initial value for this make of the car when the object is created. So let's add a method which is the constructor for this class. The one difference between constructor and normal class methods is that we don't need to specify the return type. So now let's assign the string make to our field make, and we'll use the this keyword again for that. Now we can add a method in the person class which will allow a person to drive a car. Let's go back to the person class and define a method drive here. We need to provide the person with a car. So for that we'll use the parameter car. Now let's build a message which says a person by a specific name is driving a car of a specific make. Now we want to get the make of the car using the car object. Firstly, let's create a new car object. Now let's make the person Brian drive the car. So here we can see Brian is driving a car of make Ferrari. Both the classes car and person are able to interact with each other through the use of methods. By calling methods on the objects, we can pass in one type of object to another object of the same or different type and make them interact by calling object methods. We talked a little bit about the public keyword, and we learned that it indicates that a public class can be accessed by another class. We also used this keyword when we created our methods. This allowed us to call the person class methods by using an object of this class. The public keyword can also be used on fields inside a class. However, it is not recommended, and the correct way to allow access to fields inside a class is through class methods. This is called information hiding and forms the basis of the object-oriented programming principle called encapsulation. Let me explain this with an example. Let's suppose we want to add code to allow starting and stopping a car's engine. To determine whether a car's engine has been started or switched off, we can use a class field engine on. The type of this field would be Boolean. Now, since a person needs to switch on the engine to be able to drive a car, the person class's drive method might want to do this. This indicates that the engine has been turned on and the car can now be driven. And while this looks okay, it is not okay to do this. Let me explain. Let's say when the engine is started, we'd also like to start the car's onboard computer. Without this, the car would not function properly. So let's add another class field in the car class to indicate the car's onboard computer has started too. But the person class might not bother setting this when it is trying to start the car in the drive method. So as a developer of the car class, it is our responsibility to wrap this logic of starting up the car in a method and only allow the person class to access this method and not be able to modify individual class fields such as engine on and onboard computer on. So first we'll make the fields engine on and onboard computer on private. The private keyword indicates that the field or a method which is marked private cannot be accessed outside a given class. Now let's go back to the person class, and you can see that the person class can no longer modify the field engine on because it has private access in the class car. So let's define a couple of methods called switch car on and switch car off in the car class. And now let's call these methods from the person class. This code is much cleaner and has less dependencies on the internal fields of the class car. Encapsulation allows a class to be updated much easily when new features need to be added to it by making it easier to understand. Just by looking at the methods switch car on and switch car off, we can easily identify their purpose. A Java class has the ability to inherit fields and methods from another class called the base class. The class inheriting fields and methods is called the derived class, and this is achieved using inheritance. Now let's say we want to add the ability to refuel a car. Now electric and diesel cars are refueled differently even though all are still cars. To model this in our code, we can use inheritance where our class car becomes the base class and we can provide a way to refuel it. So let's define a method called refuel in our class car. Because this is the base class and we want to let the derived class decide how it wants to refuel, we are going to define this as an abstract method. An abstract method does not have any body and it is up to the derived class to implement that method. We need to now tell Java that the car class is also abstract. You cannot instantiate or create an object of this class. You can only create an object of the derived class of an abstract class. So now let's define our diesel car class, which will be the derived class of this base class car. In Java, we use the keyword extends to indicate that one is deriving from another using inheritance. The editor is again telling us there is some problem, and the problem is that because we have defined the refuel method as abstract, Java wants us to now implement this method in the derived class. When we implement a method in the base class, we need to annotate that method with a keyword called override that tells Java that the derived class is implementing or overriding that method which is already there in the base class. Now we can simply say that we want to refuel this car with diesel. Even though we have implemented the refuel method in the diesel car class, we still have an error, and that is that the car class has a constructor which initializes the make of the car. To solve this problem, we need to call the base class constructor from the derived class constructor and pass in the make of the car. In the diesel car constructor, we are accepting a parameter of type string called make. Using the keyword super, we are calling the base class constructor when the derived class constructor is called. Now let's add a new class called electric car. Here you can see that the refuel method is different from the method in the diesel car. Now if you remember, I mentioned earlier that we cannot create objects of abstract classes, which means we will now have a problem when our person class is provided an object of the car class. As you can see, when we try to create a new car object, we get an error. We need to tell Java what kind of car the Ferrari is. So for that, we'll use the object of class diesel car. Now let's create one object of an electric car as well. Here we are creating an object of the electric car class and its make is Tesla. And we are allowing John to drive the Tesla car. Let's run the program and look at the output. As we can see, the person Brian is still able to drive his car Ferrari, and the person John is now driving a car of make Tesla. Inheritance allowed us to create two classes, electric car and diesel car, and they were able to share some attributes from the base class car. Inheritance is used especially when the derived class and the base class have a specific relation, and that relation is called is a. In our case, an electric car is a car and a diesel car is a car as well. Now I'll explain a bit about the flow control statements in Java. These allow us to build applications that can react based on certain conditions being true or false. For example, we might want to check the current weather forecast in our code and display the appropriate symbol to the user, such as sunny, cloudy, or rainy. Or we might want to calculate the sum of the first 100 numbers, but not using 100 variables, but using the looping mechanism instead. Let's write a small game called Guess the Number. In this game, the computer randomly picks a number from a range of numbers and the user needs to guess it correctly. For this, let's create a class called NumberGame. Now let's add a method to allow the user to guess the number. First, let's make the computer pick a random number between 0 and 20. For this, we'll use a method that Java provides us in a class called random. Let's have a look at this class in the Java docs and see what parameters we need to pass in the method. To find Java documentation online, it is simply a matter of going to a search engine and typing Java docs. Pick the link which has docs.oracle.com. And in here, search the documentation on the Java class called random. Here we can see the search results, and the search result here, which says random, looks the most appropriate. So let's go into that. And now we can see that this documentation describes what this class does, and it says that an instance of this class is used to generate a stream of pseudo-random numbers. So let's look at the correct method which we want. So in this case, we want to find a number which generates a random integer between 0 and 20. Okay, so the method nextInt is the one we want because it will return a random number uniformly distributed between 0 and the specified value, exclusive, which means that if we want to generate random numbers between 0 and 20, the bound needs to be 21. Let's use this method. To use the nextInt method in the class random, we first need to create an object of this class. We need to add an import statement which will allow Java to locate this class and allow us to create the class object. To import the class, simply click on the word and then you can see this tooltip which has this option import class. Click on that, then we can see that Intellij has added an import statement, and in this statement we can see that it has imported the class random in our project, and now we can create this object without any errors. Now using this class, let's generate a random number. If you remember from the documentation, this call will generate a random number between 0 and 20. Let's assign this to a variable called number. Now let's read the user's guess from the console. For that, we need to create the scanner class object. We need to import the scanner class using the import statement. If you type the word scanner, Intellij automatically suggests options. We need to select the scanner class inside the java.util package. And we need to pass in parameter for this, which is system.in. This allows us to read user input from the console. So firstly, let's ask the user to guess a number between 0 and 20. To read the number from the console, we can use the scanner class's nextInt method. Now we have the user's guess. Let's check if it matches what our computer picked. For this, we can use the if statement and compare two numbers using the equals equals comparison operator. In this block of code, I'm simply checking if the two numbers are equal by using the equals operator, and if they are equal, then what will happen is this will be true and the if condition will succeed. When the if condition succeeds, it will enter this code block inside this curly bracket and execute whatever is inside it. So in this case, I'm simply printing a message saying, hey, you guessed it right. To run the program, we obviously need to write a main method so that we can create an object of this class and call the method guess the number. Now the program is running and it is asking us to guess a number between 0 and 20. I'm just going to try putting in 2. Now if you notice, when we did not guess the number correct, nothing happened. Wouldn't it be nice if the computer told us that we did not guess the number correctly? For this, we need to write an if-else statement. So we have already got the if part of the statement. So in this case, the else block will be executed if this condition returns false. Now if we guess the number correctly, then the condition is true and it will only execute the part in these brackets and it will skip the part in these brackets. But if the condition is false, it will not execute code in the brackets here, but it will execute the code in the else part. Now let's run the program, and now I'm going to guess a number between 0 and 20. My guess was wrong and that's why the computer printed the message, sorry you guessed it wrong. So this gives us some sort of idea on how the if else works. Now so far this is a bit better, but what if we could make the computer give us more chances to guess the number again? For this, we can use a do while loop like so. Let's go back in our method and add the do while loop. So in our loop, we want to first allow the user to guess the number and then check this condition again. Do while loop will start here. To enter all of this code inside the do while loop, we can simply go to the end of that code and close the bracket for the do here. And Intellij will automatically shift all the code correctly. Now we need to add the condition which we need to check when this code has finished executing. And that condition will tell Java whether it needs to execute this code again or not. So in this case, we want the code to execute again if the number we guessed is not the number which the computer picked. Now we have a small problem here, and that is the value guess is not defined, and that's because the integer guess is inside of these brackets and its scope is restricted to these brackets only. So we need to define this int guess outside this do while loop. Now let's try to run our program and see what happens. Okay, I'm going to guess a number, let's say 6, and it says sorry you guessed it wrong, and then it's asking me to guess the number correctly again. Let's try a different number this time, and it still doesn't like my guess. So far we have established a do while loop, and then inside of the do while loop we are checking if our numbers match. It would make the game even more exciting if the computer would give us some clue. That way we will find it a little easier to guess the number correctly. Let's say the computer gives us a clue whether the number we guessed is higher than or lower than the number it had picked. For this we need a special control statement called if, else if, else. For this, firstly I'm going to stop the program by clicking on this red button here. Here we first check if the numbers match. If they don't, we check if the number picked by the computer is lower than the guessed number. If so, we give the user the clue to pick a number which is lower than their previous guess. Else, we give the user the clue to pick a higher number. Let's guess a number, and now it says you guessed it wrong. Guess a lower number. So let's try guessing a smaller number. And it says we still need to guess a lower number. And there you see, it says that we guessed the number right, and then the program finished execution. So this is how, using the if else statement, we could make our application a bit more user friendly and more exciting. That was fun, wasn't it? Another version of the do while loop is the while loop. The only difference is that the condition is checked at the start of the loop instead of at the end. The next important control statement is the for loop. Let's say we want to print numbers from 1 to 20. Don't worry, we won't code the print statement 20 times. We'll use the for loop instead. It is slightly more compact than the do while loop. For this, let's create a new class called numbers and add the main method. In this main method, I'm going to add a for loop, print numbers from 1 to 20. Here the keyword for indicates that this is a for loop. The initializer expression where we have defined the variable I executes only once. Then the condition is checked, and then the body of the loop executes where we print the value of I. And at the end of this code block, the value of I is incremented by 1 using the plus plus operator. The loop stops when the condition here returns false, and in this case it will return false when I equals 21. So we start the value of I from 1, and then we increment the value of I till this condition stops being true. Once it stops being true, then we break out of this for loop. When using the if or the if else statements, we might need to check if multiple conditions hold true or if one of many conditions hold true. We achieve these using the logical or and the logical AND operators. Let's say we want to check if the total price of two items is between $10 and $20. This is how we would check this condition. Firstly, let's define a couple of variables to hold prices. In this code, the condition inside the if statement will be true when the sum is within the values 10 and 20. When we run the program, we see the output total is within the range. Let's change the value of one of the prices and make it so that the total goes outside the range. Now the total should be 155 and it is definitely beyond our range. Here we can see the output total is outside the range. Another commonly used logical operator is the OR operator. Let's see how it works. If you remember this for loop, we were printing numbers from 1 to 20. While we are printing the numbers, let's say we want to print hello instead of the number if the number is 6 or 18. We would do it like so. Here we are simply checking whether the number is 6 or the number is 18. And if this condition is true, then we are printing hello, else we are simply printing the number. Let's look at the output. Here we can see that after 5, instead of printing 6, it's printing hello because I equals to 6, and When it's time to print 18, it's printing hello again because I equals 18. Now let's look at arrays and collections in Java and why we need them. In order to store multiple values or objects of the same class or type, Java provides two types of data structures, namely arrays and collections. Arrays are fixed in size, that is, once the array with the specified size is declared, then we can't alter its size later on. Collections, on the other hand, offer flexibility and can grow in size if we need to add more elements later on. Let's say we wanted to find the sum of 5 numbers. Since arrays and collections allow storing multiple values or objects of the same type, let's create an array of size 5 and store 5 numbers in it. But first, let's create a class to add our code into. We define an array using the brackets next to the data type like so. Here we create a new array of integers and specify a size of 5. We can then store up to 5 numbers in this array. To access each element of the array, we need to tell Java the position where we would like to store the number, and the numbering system starts from 0. Similarly, if we wanted to read a number back from this array, we need to tell Java at what position we want to read our number from. So firstly, let's store some numbers in this array. Notice now that we have added 5 elements into the array. If we try to add a 6th element, Java will throw an error, which is also called an exception. More on that shortly. Now that we have stored our numbers in the array, let's add all the values together. We could do the following to add up all the values and assign it to an integer. But there's a much simpler way to do that, and that's using the for loop. Since we want to add the elements at index 0 all the way through to 4, we can write the following. Let's define an integer to hold the total of all the values. In this for loop, I have defined a variable I which starts with the value 0 and goes all the way up to 4, and every time it's incremented by 1. So we start by adding the first element, which is nums of 0, which is 10, into the total. After that, I is incremented to 1, and then we add the second element in the array, which is 4, into the total. And this way we can add all the 5 numbers into the variable total and finally print the value of total. Now what if we had decided to change the size of the array to say 10? In that case, our program would need to be altered. To change this, there's a better way to do it which works with any size of the array, and that's to use the length of the array. Now notice that I have changed the condition from less than equals to less than. So when I becomes 5, this loop will stop and will only be accessing the values in the array up till index 4. Let's run and see the output. The output is 39, which is the sum of all these 5 numbers. Now let's turn our attention to collections in Java. As I mentioned earlier, collections offer the flexibility where they can grow in size if we want to add more elements than the size of the collection. One of the most commonly used collections in Java are array list, linked list, set, hash map, etc. Let's store the same numbers in an array list and add them up and print the output. To create an array list, we need to use the array list class like so. And now we need to tell Java what we need to store in the array list. So we need to use the notation of the angular brackets to tell Java what type of data we're going to store. We need to use the reference type or class type objects. The class type object or reference type object equivalent to the int data type is called integer. This is how we define and create an array list of integers. Now let's store some numbers in this array list. Now as before, let's add up all these numbers using a for loop. In this for loop, I have initialized the variable I again to 0 and it goes all the way up till 4. And every time I'm getting the number stored at position I using the get method and adding it into the sum. Finally, I'm printing the sum onto the console. As you can see, the same output again, with just that we used an array list instead of array this time. Let's talk about exceptions. An exception is an event which occurs during the execution of a program that disrupts the normal flow of the program. For example, if we were reading numbers from the console from a user, such as in our number guessing game, and the user entered a name instead of a number, our program would encounter an exception because it will complain that it was expecting a number but instead got a string. Exceptions are classes in Java, and Java provides various built-in exception classes. It also allows us to write our own. Let's look at one of the Java's built-in exception classes. Let's go back to our numbers game and try entering a name instead of a number. So the program is asking us to enter a number, but let's say we put some string or some random characters. We get an exception, and the message is exception in thread main, which is our main program. And the name of the exception class is input mismatch exception. This tells us that there is a mismatch between what the program was expecting and what the user entered. Now, as a user, we do not want to see these kind of messages on the screen. So as a developer, we need to handle exceptions, and that makes our program more robust and reliable. Let's see how we can make our program handle this sort of bad input. Now we know that when we entered a string instead of a number, and that caused Java to throw an exception. One way to handle exceptions in Java is to use the try-catch block. Inside this block, we add the code which we expect to throw. So when the exception happens, the code which fails is set to throw an exception. This is the try block, but we now need to catch the exception which will be thrown when the user enters bad input. And if you remember the error from earlier, the name of the exception was input mismatch exception. Let's just call the variable e. And now we have caught the exception here. We can tell the user that they have entered a bad input and they should only enter numbers. I'm simply going to terminate the program if they entered an invalid input. Now this is another interesting thing to learn. Even though our method has a return type void, it does not stop us from returning out of the method at any given point. We do not necessarily need to return a value. We can simply use the keyword return, and at that point our function or the method will stop executing and the flow control will go back to the caller of the method, that is the main function. Let's try putting a number to start off with, and this time let's put some string. And now you can see we have a nice message displayed on the screen which says numbers only. So this is how we can handle exceptions and make our code more robust and reliable. That's all for this video. I hope this video helps you in learning programming with Java. If any concept I explained was not clear enough, please leave a comment and I'll try and help answer. I will add a link to the source code in the description of this video. Please remember to subscribe to my channel and also like and share my videos. Thank you for watching.